So for this question, we've got a savings account is modeled by a recurrence relation where n is the number of months since opening the account. And for part A, we need to find the balance after 2 months. So the first thing that we're going to have to do here is we're going to have to find A1 by using our recurrence relation. So I'm going to substitute AO in, and that gives us an answer of 2005. Then to find A2, we just repeat the same process. I'm going to use 2005 as A1, and then we get an answer of 2010 and 1 cent, rounded to 2 decimal place. So nothing complicated there for part A. For part B, we have to calculate the balance at the end of the year. So because we're dealing with months in this situation, if we want to find the balance at the end of the year, then we want to find A12. So the way to do that is we would have to find A3, then we'd have to use A3 to find A4, then we'd have to use A4 to find A5, then we'd have to use A5 to find A6. And we could just keep repeating that process, but you can probably see how that can become quite time consuming, and there's a lot of things that you have to constantly enter into your calculator. So a way around this is to use the calculator trick. So how the calculator trick works, right? So if we look at A3 here, right, that answer, once we enter that into the calculator, that value is stored as the answer on your calculator. So we can now use the answer button to type in 1.0025, which is just the number from our recurrence relation, times by the answer. If we hit the answer button and then hit equals, that'll give us A4. Now what we can do is we can just continue to press equals. So to speed up the whole process, we just hit equals, 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 equals. And what that will do is that will tell us what A5 is, A6, A7, A8, etc. We do just have to remember to keep count as you're going. So when I'm doing this and I'm hitting equals, 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 I'm generally kind of counting in my head going A4, A5, A6, A7, A8, until I get up to A12. So using the calculator trick, we get $2,060.83. I'd encourage you to test this yourself just to make sure that you can definitely use the trick, because this trick is very, very valuable and it's something you have to know when it comes to recurrence relations. Okay, so let's go through another example. There was a typo here too. It says where n is the number of weeks. That should say where n is the number of months. So for part A, we want to calculate the balance after 8 months. Well, I've got to find A1 first, and then A2, and then A3, etc. So I've just plugged in 50,000 for AO. Now I can start using my calculator trick. So I can just type in 1.004 times by answer minus 500. And then I can just keep clicking enter, 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 enter until I get to A8. Now part B, it says calculate how many months until the loan is paid off. So what I'm going to have to do here is I'm going to have to keep continuing to hit the equals button until I've either got 0 or less than 0, which would indicate that we don't owe anything more on the loan and therefore it's been paid off. So all I'm going to do is just continue to click equals, 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 equals. And it just so happened that when I did that, I had to click the equals button 128 times until I got a negative value. So what that means is after 128 months, this situation would be paid off, which is the equivalent of 10 years and 8 months.